we're going to go ahead and take a look at finding the area in between two curves. In a way, we've already been doing this. We've already found the area underneath a function all the way down to the x-axis. The x-axis is really the curve y equals 0. And so we've been finding the area between two curves with the special curve y equals 0, the x-axis, and your curve. And for the most part, it's really taking the top function here minus your bottom function. Now, if you wanted to find your area over here, really all you do is you find the area underneath your whole top function, and that's what we're doing here. Find the area underneath your bottom function, that's what we're doing here. To get that pink area, all you do is you subtract those two answers, and it gives you this pink area. So in general, to find the area in between two curves, you take your top function minus your bottom function, and you integrate that. So we need to go ahead and find the area between our two curves here. Here we have our top function being our parabola, our bottom function being the negative x. So we would need to take our top function minus our bottom function. Notice we're integrating here from 0 to 1 because you're asked to find your area between 0 and 1. So on your graph, that's the shaded pink area here. So now all you have to do is just integrate each one. You integrate your x squared, integrate your 2, and you get your 2x. You're going to have a minus, which is a plus x. And when you integrate plus x, you get this right here. Evaluated that from 0 to 1. So plug in 1, subtract what you get when you plug in 0, and you get the area. Well, same idea here. We're going to have to take the top function minus the bottom function and integrate. The question is, how far do we have to integrate from left to right? We got to find this a and this b. We got to figure out where they cross. Well, to figure out where the two functions cross, set them equal to each other. Solve it for x. In this case, it's just a nice normal quadratic. It does happen to factor. And so then you get your two answers to be a negative 3 and a positive 2. And so on your graph, you could put a negative 3 here, put a positive 2 here. You know you're going to have to integrate between those two. So once again, you want to take the top function, which is our curved parabola, subtract the line underneath, and then all you have to do is integrate. You integrate your x squared, your negative x squared, integrate your negative x, integrate your 6. And then all you want to do is plug in 2 for all your x's, subtract what you get when you plug in negative 3, and you get in 125 over 6. Well, here we need to go ahead and integrate. We will need to find this area here. You'll notice, though, that we don't necessarily have one function always on top. In this area right here, we have our line being on top, and then our curve is on the bottom. However, when you get to the right-hand side, you have a curve on the top, and then you have that same curve again on the bottom. So what we need to do is we really need to integrate this in two pieces. We'll integrate the first red and orange piece here. So you're going to take the top function here, which is the red one, minus the bottom function, which is the orange one over there. And yes, you do need to go ahead and solve your y squared up here for y. So you get y is equal to plus or minus the square root of 8 minus x. And since you're dealing with the bottom half of your sideways parabola, that's why it's the negative root here. Now this one here, the red line is only on top from x being negative 8 all the way over to an x being 4. So we're integrating from a negative 4 to 8. Now when we do this one here, we got to take our top function, which is the positive root, minus the bottom function, which is the negative root, so that's why we're subtracting a negative. By the way, this right here does simplify a little bit. It gives you 2 of those roots. This here does simplify just a little bit. I wrote it as a 1/2 power because you may find it easier to integrate. So now you're going to integrate your 1/2 x. Integrate this here, so you know you're going to have to increase your exponent by 1, which is a 3/2, so that means you're going to have a 2/3 in front. Might be wondering why we have a negative here. That's because you got to undo the derivative of the inside, which is a -1. Same type of thing over here. You did have a 2 here, but then you got to undo your 3/2, so you'd have to have a 2/3 in front. The 2/3 with that 2 in front is your 4/3. The negative comes from the chain rule. So all you have to do is plug 4 into the first one, subtract what you get when you plug in 8, add that to what you get when you plug in 8 here, and subtract what you get when you plug in 4. And so then you end up with 36. Now there is an easier way to do this problem. Because back here you'll notice there wasn't always one function on the top. But there is always one function to the right. So as you're looking at this, this function here is always on the right-hand side. And this function here is always on the left side. So before, when we were integrating, we'd always take the top function minus the bottom function. Top function because it was farther up in the positive direction. So similarly, when we're going sideways here, we're going to take the function that's farther in the positive direction, which is always going to be the function on the right, minus the function that's not as far over, which is always going to be the function on the left. So you're going to take the function on the right, but now, since we're changing the way we're integrating, instead of having basically vertical rectangles going up and down, which is a dx, we're having horizontal rectangles going up, which is having a width of a dy. So we need to have everything in here, since we're integrating with respect to dy, in terms of y's. So here's your function on the right. Now your function here on the left was initially a y is equal to a 1/2 x. You need to go ahead and solve that for x so that you can go ahead and plug that in, because you need to have y's in here, not x's. Now since you're integrating with respect to y, you then need to make sure you have y values for your bounds. So you're starting out at a -4, going all the way up to a height of a 2. And so now you're just going to integrate. Then you have to evaluate. Now you'll notice this integral, even though we're finding the exact same answer as we were in the last problem, it's much nicer to integrate. It's much nicer to evaluate. You plug in your 2, subtract what you get when you plug in your -4, and lo and behold, we still get the same answer of a 36.